Good afternoon, students. Yesterday, students, in ITC, we have seen till now in our video lectures we have seen about different type of channels that are being used in ITC. So we have seen there are four types of channel that are being used in the field of ITC. The first one was lossless channel. Second one was deterministic channel. The third one was BSC, binary symmetry channel, and the fourth one that we have seen was noiseless channel. So till now we have seen different type of channels that exist in information theory, and in our last class we have seen a numerical on how to calculate output probability using input probability and channel metrics. We have seen what is the fun of using channel metrics. So yesterday we have come to one conclusion that if we want to calculate output probability, it is given by input probability multiplied by py/x, that is channel probability. This is the first thing that we have studied yesterday in our numerical, that in order to calculate the output probability we need to have matrix multiplication of input probability and channel metrics. In the second part of the numerical yesterday we have seen that if we want to calculate joint probability, that is px comma y, what we have to do is we need to find out the diagonal matrix of input probability and channel matrix. So if we will multiply the input probability in diagonal form with channel matrix, in that case we will be able to find joint probability. So from here we can write like this. There is one more thing that we need to know is, that is joint probability when seen from transmitter side and the joint probability when seen from receiver side. Both of them are one and the same thing. So from here we know that input probability, whether we will be watching from the transmitter, so here we are able to see that joint probability, whether we are seeing from the transmitter side or from the receiver side, both is one and the same thing, and its value is pxi into pyj/xi. Yj/xi means channel matrix. So from here we can write down like this also, that pyj/xi into pxi is equal to pyj into pxi by yj. So this is from transmitter side, this is from receiver side. I have written down the full values of joint probability when seen from transmitter side and joint probability when seen from receiver side. So from here we can write like this, that pxi/yj, this pxi/yj, this is not the channel matrix, this is from the transmitter side, that is from the receiver side, that is pxi upon yj. This means that what is the probability of receiving, what is the probability of transmitting xi when yj has already been received. So this means what is the probability that x1 has been transmitted when yj has already been received, and this is not channel matrix. I am repeating again, this is not channel matrix. So how we are going to calculate pxi upon yj? So this is equal to pxi into pyj/xi divided by pyj. Similarly, just we have cross multiplied this yj and it will come in the denominator side. So this is how we calculate pxi by yj. So today students, first of all we will understand how to calculate channel capacity. We have seen few formulas till now, and today we will be watching how to calculate the main thing, that is the channel capacity. So first of all today we will find the channel capacity of deterministic channel. I will be showing you how to calculate the channel capacity of deterministic channel. So we already know what do we mean by deterministic channel. It is something that is having channel matrix like this way, that is 1 0 0 1 0 0 0 1 0 0 1 0 and 0 0 1. This was the deterministic channel that we have studied in our last lectures. So I'm taking the same matrix of deterministic channel. Here we are able to see that the number of inputs are more and the number of outputs are less. We are having 5 inputs and we are having only 3 outputs. One thing more, before moving to this topic, one thing more is there that I want to clear all my students, that you should understand one more thing. One more thing is that yesterday we have seen that this is the joint probability matrix. Yesterday in the numerical we have seen, I will be showing you the numerical again that we have done yesterday. So this was the numerical that we have studied yesterday, that there was a BSc and we were having its channel matrix, and from that channel matrix we were able to calculate the output probabilities, and the output probabilities that we calculated were 0.55 was the output probability of getting y1 and 0.45 was the probability of getting y2 at the output. So I have written it down here, y1 was 0.55 and y2 was 0.45. So after calculating the output probability, we started calculating the joint probability. So in our last lecture, we have calculated the joint probability and we have been able to see that the joint probability was this. After the calculations were over, the joint probability was this matrix. So from this matrix, you are able to see that if we will add the joint probabilities row wise, if we will add the, I will repeat it again, if we will add the joint probabilities row wise, they will be equal to input probabilities. They will be equal to input probabilities. So if we will add them row wise, they will be equal to input probability. So 0.45 plus 0.05, this will give 0.5, which was the input probability of x1. Similarly, 0.1 plus 0.4, this is equal to 0.5. That was the input probability of x2 that we have taken yesterday in our numerical example. Similarly, if we will add the joint probability column wise, you are able to see we are getting 0.55 and 0.55. This is the output probability of getting y1 and output probability of getting y2. So what I want to tell you is that this is the joint probability matrix, and if we will add it row wise, xi comma yj, row y means all the values of y will change, that means j is changing whereas x is constant, so we will be getting probability of xi. Similarly, if we will change the value of I in joint probability, we will be getting pyj. So this means you are able to understand, hai na? We are changing the values of I, that means x1 yj, similarly x2 yj. So if we will be changing the values of I, x1 and x2, j is same, j can be y1, can be y2. We have taken, let us say, y1 here. So in both cases y1 is there. So x1 y1 plus x2 y1, that is 0.45 plus 0.1, that will give output probability. That will give output probability j. So you need to remember these two formulas as well. So I will be writing these formula. So you also write down here in the formula section. This is our formulas that we have seen till now. So the next formula is that if we will add the joint probabilities with variable I means x1, x2, x3, I is varying whereas y is constant, this will produce output probability. And if we will vary the value of j in joint probability, this will produce input probability. So this is the benefit of joint probability. If you will add joint probability row wise, you will be able to calculate input probability, if you will add joint probability column wise, you will be able to calculate the value of output probability. Now we will again move back to the topic which we have started, that was channel capacity of deterministic channel. So we know how do we calculate channel capacity. Channel capacity is equal to maximum mutual information. Maximum mutual information. Mutual information is I x semicolon y. The maximum value of mutual information is called as channel capacity. So now, what is the value of mutual information? Mutual information is equal to hx minus hx slash y or hy minus hy slash x. This was the value of mutual information, and the maximum value of mutual information will give us channel capacity, where hx stands for source entropy, hx slash y is a conditional entropy. Similarly, hy is source entropy and hy slash x is a conditional entropy. So now we know that, let us say we have taken hy minus hy slash x as our formula for calculating mutual information. I have taken this formula at this moment. We can take any of the two, but I have taken this one for this moment. So we know the value of hy is, that is pyj. The value of hy is pyj log base to 1 by pyj for all values of j. This is called as entropy. This is the formula for entropy, that is pyj log base to 1 by pyj. Now, what is the value of, this is hx, and what is the value of hy slash x? This is equal to summation of all values of I, all values of j, p xi comma yj log base to 1 by p yj slash xi. This is the formula for hy slash x. So now what we will do is, we will open the value of pxi yj. This is equal to, we know the value of joint probability is calculated using input probability multiplied by channel matrix, that is yj upon xi log base to 1 by pyj slash xi. So in this particular case, that is deterministic case, we are able to see that the value of channel matrix is either 1 or 0, because there is only one element that is active in one row, so that's its value must be 1, hai? So we know that in this case, because any input will come to output, that's why the value needs to be 1, and there is only one element, hai? So we can't go to second output. So hope you will be able to understand that the value should be 1 or 0. So in case the value is the value of pyj slash xi, it can be only 0 or 1. So in case its value is 0, let us say the value of channel metric is 0. So 0 multiplied by anything blah 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 will remain 0. And if the value of pyj slash xi is 1, what will happen? Ij pxi into 1 log base to 1 by 1. Because the value of yj upon xi is 1. So this means this is equal to log base to 1. And what is the value of log base to 1? This is equal to 0. So log base to 1 will again reduce to 0. So 0 multiplied by anything will be 0. So from here we are able to see that the value of hy slash x will remain always 0 in the case of deterministic channel. So what is the channel capacity for deterministic channel? If the value of hy slash x is always 0, what is the value of maximum mutual information? That is hx, that is maximum source entropy. This is the channel capacity. This is the channel capacity for deterministic channel. Thank you, students. That's enough for today.